Lesson 60, Cache. 1. Introduction. The feature called cache is designed exclusively for React Server components. Its purpose is to cache the result of a data fetch or an expensive computation so that repeated requests for the same work do not cause redundant processing. This approach improves performance and reduces unnecessary server load. When you use cache, you create a memoized version of a function. The memoized function remembers previous results based on the specific input arguments it receives. If it is called again with the same arguments, it will return the previously stored result instead of recomputing it. This stored result may be a value, a resolved asynchronous value, or even an error. Calling cache with a function produces a memoized version of that function. It should always be called outside any component so that it can be shared across the application. The memoized function behaves just like the original one, except that it checks an internal cache before performing the work. 2. Usage. 2.1 Cache and expensive computation. This use case focuses on avoiding duplicated work. If multiple components require the same expensive calculation or need to process the same input data, the memoized function ensures that the computation is performed once and shared across all call sites. If one component calls the memoized function and no cached result exists, the function performs the work and saves the result. Later, if another component calls the memoized function with the same arguments, the cached result is returned instantly instead of recalculating. This behavior also applies when components render in different parts of the tree or even under different conditions. The key idea is that all components call the exact same memoized function so they share the same cache. If different components create their own separate memoized functions, each one will maintain an independent cache, leading to duplication of work. Another case to consider is when the expensive computation supports cancellation via a signal. In such cases, the cache mechanism can cooperate with cancellation to stop work that is no longer needed. There is an important pitfall. Creating a memoized function inside a component generates a new independent cache each time that component renders. This breaks cache sharing entirely. To maximize performance, memoized functions must be defined in a shared module that components can import. 2.2 Share a snapshot of data. By memoizing a data fetching function such as a network request, you allow different components to share the same snapshot of data as long as they request it using the same arguments. When two components ask for the same data, only one request is made. Both components then read from the same cached snapshot during the server render. If the components supply different arguments, then the underlying fetch occurs separately for each argument. In this scenario, each unique argument serves as a cache key. It is important to note that asynchronous rendering is only supported in server components. In client components, you must use techniques designed for asynchronous data such as the use mechanism. 2.3 Preload data. By calling a memoized function early, before actually needing the data, you can begin a long-running asynchronous operation in advance. This allows the server to perform part of the work while rendering continues. When the component that actually uses the data renders later, it invokes the memoized function again. If the earlier call has already completed, the component immediately receives the cached result. If the earlier call is still pending, the component waits for that work to finish. Either way, preloading reduces end-to-end wait time. This pattern is valuable when you want to overlap data fetching with other server computations or rendering operations. 3. Deep dive. 3.1 Caching asynchronous work. Memoizing asynchronous work means the cache stores the promise representing that work. The promise tracks whether the work is pending, fulfilled, or failed. When the memoized function is first invoked, the promise is created and stored. Future lookups return the same promise, ensuring that multiple parts of the application reference the same in progress or completed result. A non-awaited call merely initiates the work and stores the promise. A later awaited call retrieves the same promise, waiting only if the operation has not yet completed. If the promise has already been fulfilled or rejected, the awaited call resolves immediately with the final outcome. 3.2. Pitfall. Calling a memoized function outside of a component will not use the cache. React exposes the cache through a context accessible only to components. If the memoized function is called outside the component tree, it will still perform the work, but will not use or update the cache. To benefit from memoization, the function must be called within a component during rendering. 3.3. When should I use cache, memo, or use memo? These three APIs all involve memoization, but they target different scenarios and have distinct characteristics. Use memo is intended for client components. It caches expensive computations within a component across re-renders, but its cache is local to that component instance. It does not share cached results across different components. Cache is intended for server components. It memoizes work such as data fetching or expensive calculations, and the cached results can be shared across multiple components. The cache resets for every server request. Memo is used to prevent unnecessary component re-renders when props have not changed. It memoizes the rendered output of a component, not arbitrary computations. It only caches the most recent render. 4. Troubleshooting. My memoized function still runs even though I've called it with the same arguments. Several issues may be responsible. A. You may be calling different memoized functions. Each memoized function has its own cache. B. You may be calling the memoized function outside a component, which prevents cache usage. C. You may be passing non-primitive arguments such as objects or arrays. Even if two objects contain identical values, they are not considered equal unless they are the same reference. React checks for cache hits using shallow equality. Passing primitives such as numbers or strings works because they compare by value. But objects, arrays, or functions only match if they are the exact same reference. To ensure consistent caching, either pass primitive arguments or ensure that multiple calls share the exact same object reference.